let's go ahead and get started. Numbers 1, 3, left in the directions say to perform the indicated operation. And so here we go on number 1. Notice we are combining two polynomials. They are not multiplying, they are combining. There's a positive sign in front of this parentheses and a positive sign in front of this parentheses. So we simply combine our like terms. For example, I have an x cubed term here. There's no x cubed term over here, so bring down your 4x cubed. I have an x squared here and an x squared here, a positive 2 and a positive 1. That's a positive 3x squared. I have an x term here with no x terms over here, so bring down your positive x. Then I have a positive 1, negative 5. That's a negative 4. Alright, let me quickly check the back of the book, and let's continue on. Alright, moving on to number 3. We're still combining two polynomials. I have a positive sign in front of this parenthesis, so nothing will change on the inside. However, if you look at the second parenthesis has a negative sign out front. So all of these signs on the inside will change. So your x squared becomes negative. Your 2x becomes negative. And your negative 1 becomes a positive 1. Now let's combine like terms. I have a 9x squared and a negative 1x squared, and that would give you 8x squared. Then we have a negative 3x and negative 2x. That's a negative 5x. Let's cross these off as we use them. And then I'm left over with two constant terms, negative 4 and positive 1. If you combine those, you'll get a negative 3. And there we go. Let me check the back of the book real quick. And that is the correct answer. Moving on to number 5. Okay, now here, we're multiplying this 2x times this parentheses. So we're going to take the 2x and we're going to multiply it through, okay? So 2x times x squared is 2x cubed. 2x times 3x is positive 6x squared. 2x times negative 4 is negative 8x. Alright, there we go. There's no like terms that we can combine. That is our final answer. Let me check the back of the book real quick. And that is correct, number 7. Okay, we're multiplying a binomial times a binomial. We should know what to do with these by now. You take this x and you multiply it through. Then you take this positive 6 and you multiply it through. So here we go. X times x is x squared. X times negative 6 is negative 6x. 6 times x is positive 6x. And positive 6 times negative 6 is negative 36. Okay, these cancel out, negative 6x, positive 6x, and you're left with x squared, negative 36. Alright, let me take a look at the back of the book here, and that is correct. Moving on to number 9. Okay, we have a binomial times a trinomial, okay? Now I know it's multiplication because the two parentheses are side by side. So I'm going to take this x and multiply it through. Then take this negative 3 and multiply it through, okay? Watch your signs when you distribute the negative 3. Alright, here we go. X times x squared is x to the third power. X times x is positive x squared. X times negative 7 is negative 7x. Negative 3 times x squared, negative 3x squared. Negative 3 times x, negative 3x. Negative 3 times negative 7, positive 21. Now let's combine like terms. I have 1x cubed. I have a x squared, positive 1, negative 3. That's a negative 2. Negative 7, negative 3 for your x is negative 10x. And then bring down your positive 21. And there we go. Alright, let's take a look at the answer key in the back of the book. And it looks like that is the correct answer. Moving on to number 11. Alright, x plus 9 squared means you're going to write the x plus 9 two times like this, okay? You do not multiply the 2 through and get x squared plus 81, okay? You cannot do that because you have two terms on the inside. And whenever you have two terms like this, you cannot take the power and multiply it through. exact same thing we did back here when we had a binomial times the binomial number 7. X times x is x squared. X times 9 is positive 9x. 9 times x is positive 9x. 9 times 9 is positive 81. Combine your like terms. 9x and 9x would be 18x. Bring down your positive 81. And there we go. Let's check the back of the book to make sure that is correct. And it is. Alright. So moving on now to the next section, which would be numbers 33. Let me look here real quick. 33 through 33 through 42, and the directions say to factor. Okay, so we are going to factor. Here we go. Now remember, first of all, step 1, always pull out what's common. Okay, there's not an x in both terms, but there is a number that goes into 16 and 144, and you want the largest number that goes into both of those. Well, actually 16 goes into both those numbers, so we're going to factor out a 16, and we're left with this right here. 16 times x squared is 16x squared. 16 times negative 9 is negative 144. Now that we've pulled out what's common, what are we left over with? We're left over with a binomial, and it's factorable because I have perfect squares, and the first term is positive, the second term is negative. Now if the second term was positive, then you could not factor it. Okay, so because we have a binomial here with two perfect squares, we write two little parentheses. Remember, the square root of x squared is x and x. The square root of 9 is 3 and 3. Make one positive, make one negative. And there, we're finished now. We know we're done because these two parentheses cannot be factored any further. We do not have perfect squares here, and we do not have perfect squares or perfect cubes actually in either one of these two parentheses. So this is the correct answer. Alright, let me check the back of the book real quick. And that is correct. Moving on to number 34. Okay, we're going to pull out what's common. However, there's nothing common. So we look at what's left over. It's a binomial. Do we have perfect squares or perfect cubes? Yes, we have perfect squares. Well, if we have perfect squares, the first term has to be positive, and the second term has to be negative. And we have that. We have that, so we're fine. So if we're dealing with perfect squares, we write two little parentheses. The square root of 4x squared is 2x, so we put a 2x here and a 2x here. The square root of 49 is 7, so we'll put a 7 here and a 7 here. Make one positive, make one negative. Now we know we're finished because neither one of these two binomial parentheses have perfect squares or perfect cubes. And let me check the back of the book, and we are correct. Moving on to number 35. Okay, now we're looking at but first of all, we're going to pull out what's common like always, okay? However, there's nothing common here that I can factor out. So I look at what I'm left over with. It's a binomial. Do I have perfect cubes or perfect squares? Well, I do have perfect cubes. Excuse me for yawning. This is a perfect cube here. I know the cube root of 125 and the cube root of x cubed. And 8 is also a perfect cube. So here we go. Put a little parentheses for a binomial, and then put a trinomial parentheses. The cube root of 125 is 5. The cube root of x cubed is x, so the cube root is 5x. The cube root of 8 is 2, so we'll put a 2 here. Take this negative sign and bring it down and put it right here. Now, after you've done that, you take this term here and you multiply it by itself. So 5x times 5x is 25x squared. You take this term here, multiply it by itself. 2 times 2 is 4. Don't worry about the signs, okay? Take this term here times this term here. 5x times 2 is 10x. That goes right in the middle. Now, whenever this is negative, everything over here is positive. You have to memorize that. Now, when it comes to taking this and factoring it even further, please don't forget this. When you're factoring perfect cubes, the trinomial parentheses will never be able to be factored again. So just ignore that. However, this might be factorable. Let's say it's a binomial right here. Do I have perfect squares or perfect cubes? No, I do not. So that is my final answer. Always learn to check to see if you can factor um, your answer further. Let's take a look at number 36. Alright, now, first of all, we always want to pull out what's common, okay? And in this case, there's nothing common that goes into any of these numbers. So next I say to myself, do I have perfect cubes or perfect squares? Well, I have perfect cubes. And if you don't recognize that, you can always use a calculator and take the cube root of these numbers and see what you get. The cube root of 64 is 4, and the cube root of 343 is 7, okay? And the cube root of x cubed is x. So I'm factoring perfect cubes, okay? So I'm going to put a little binomial parentheses, then a bigger trinomial parentheses. The cube root of 64x cubed is 4x. The cube root of 343 is 7. This is the middle sign of positive, so bring it down and put a positive. Now take your first term and multiply it by itself. 4x times 4x is 16x squared. Take this and multiply it by itself. 7 times 7 is 49. Now multiply these two terms together. Don't worry about the sign. 4x times 7 is 28x. Whenever this is positive, this will be negative right here, and this will be positive here. You just gotta memorize that, okay? Remember, when you're factoring perfect cubes, this cannot be factorable anymore, ever, the trinomial. However, maybe this can be factorable here. Let's see. Do I have perfect squares or perfect cubes? No, I do not. So this is the final answer. And so let's see if that's correct. And yes, it is correct. Alright, moving on now to number 37. Alright, now pull out what's common first, but there's nothing common. So I'm left over with a trinomial. Now my exponent is 2. My exponent is 1. This is twice as big as this, so that's good. I have a lead coefficient of 1. That's the easy kind of trinomial to factor. So here we go. What two numbers would multiply together give me 22? When combined, give me a negative 9. Well, if I multiply those two numbers, I will get a negative 22. If I combine them, I'll get a negative 9. So I'm going to write x negative 11, x positive 2. There we go. And that's it. If you'll look at each binomial, you will see that it cannot be factored further because I do not have perfect squares or perfect cubes. Number 38. Alright, I have a trinomial with a lead coefficient of 1, so this should be pretty easy. First of all, make sure this exponent here is twice as big as this exponent here, and it is. Next, ask yourself what two numbers would multiply together give you a negative 9, when add together give you a positive 8. And I'm thinking of a positive 9 and a negative 1. When you multiply those, you'll get a negative 9. When you combine those, you'll get a positive 8. So the factorization is x positive 9, x negative 1. Now we cannot take that further because each of your binomial parentheses, each one of those do not have perfect cubes or perfect squares. Let me check the back of the book to make sure we have not made a mistake, and we are good. Let's move on. Number 39. Okay, now we have a trinomial with a lead coefficient that's not 1. So these are a little more difficult. Okay, let's see what happens here. First of all, make sure your exponent here is twice as big as this exponent here, and it is. Secondly, because we do not have a lead coefficient of 1, we multiply this number times this number and put it over here. So we get 4. Are there two numbers that when you multiply them, they get negative 4? When you combine them, we get a negative 5. The answer is yes. If you multiply these two numbers here, you get a positive 4. And if you combine them, you get a negative 5. Now before you start to go like this and put your parentheses, remember, that works when you have a lead coefficient of 1. We do not have a lead coefficient of 1. We have a lead coefficient that is not 1. So you have to do it differently. You bring down your first term, and you bring down your last term. And then right in the middle, because we have an x here, we take this number, and we put negative 4x. We take this number here, we put negative 1x, or just negative x. So we've rewritten our trinomial as a quadnomial. So now, we pull out what's common in our first two terms. Well, 2 goes into 2 and 4. I can pull 1x out, and you're left with x negative 2. Over here, there's nothing I can pull out, so I pull out a 1, but make sure it's negative because this negative sign here. And then because I have x minus 2, let's put x negative 2 over here. Let's see if that works. Negative 1 times x is negative 1x. Negative 1 times negative 2 is positive 2. So we are looking really good, right? You're matching parentheses once. And then what's left over is 2x negative 1. Okay? So there we go. Guys, look at your two parentheses. They're both binomials, and neither one has perfect squares or perfect cubes. So we cannot factor this any further. Number 40. Okay, we have a trinomial that does not have a lead coefficient of 1. It's got a lead coefficient of 3. So it's going to be a little more difficult. First of all, let's make sure this exponent here is twice as big as this exponent here, and it is. Next, let's take this first number here, 3 times negative 20, and let's see if we can get a pair of numbers. If we can't, then we can't factor it. Okay, what two numbers would multiply together give me a negative 60? When combined, give me a negative 11. Well, I'm thinking of this. If you multiply those two numbers, you'll get a negative 60. If you combine them, you'll get a negative 11. Okay? So remember, bring down your first term. Bring down your last term. And then I have an x here, so I take this number, put it with an x. Positive 4x. Negative 15, put it with an x. Negative 15x. Now, pull out what's common in the first two terms. That's an x. And you're left with 3x plus 4. Pull out what's common in these two numbers, which is a 5. But make it negative. There's a negative sign here. And then let's put 3x plus 4 because that's what we have over here. And let's see if that works. Negative 5 times 3x, negative 15x, negative 5 times 4, negative 20. So it does work, right? You're matching parentheses once. And then your leftover terms will be x negative 5. Now, we are finished because this binomial and this binomial, neither one of those have perfect squares or perfect cubes. So we cannot factor it any further. We check this in the back of the book and we are good. Moving on to 41. Okay, now, we are going to factor this quadnomial. The first thing you do is you pull out what's common, and there's nothing common I can pull out of all four terms. So next I say to myself, I have a quadnomial. How do I factor a quadnomial? Well, you pull out what's common in the first two terms. So you can pull out 2x's out of both terms. You're left with this. Now over here you can pull out a 5, and it will be a positive 5 because of the positive sign here. Right here. And so, because we have x minus 1 here, let's put x negative 1 here. 5 times x, 5x, 5 times negative 1, negative 5, so we're good. Right, you're matching parentheses once. And then bring down your x squared positive 5. Okay. Hey, let's move on. Here we go. Now, it looks like we can factor this further, but no, we can't. We do have a perfect square here, but not here. So I do not have perfect squares or perfect cubes. Sorry for yawning at either one of my two binomial parentheses. So that's as far as you can take this. Okay, let me check the answer key real quick. And we are moving on. Number 42. Alright, we're going to factor a quadnomial again. Now, always pull out what's common first. Notice there's nothing common you can pull out. So next, we're left over with a quadnomial. Let's factor this quadnomial. So we're going to pull out an x squared out of the first two terms, and we're left with x negative 3. Here we can pull a 5 out of the 5 and 15, and because of the negative sign here, we'll pull out a negative sign, and we're left with x positive 3. And actually it'd be a negative 3, sorry about that, that's what I have over here, is a negative 3. And let's see, negative 5 times x, negative 5x, negative 5 times negative 3, positive 15. So we'll write our matching parentheses once. And then our other terms, x squared negative 5 right here. Now we are finished because neither one of these two binomial parentheses are perfect squares or perfect cubes. So that's as far as we can take it. Let me check the answer key real quick. And we are good. Okay. Alright, let's move on to the next section of our review sheet, which would be, let me get my book open here, get my book to the right page, I should say. The next section we're going to find real solutions of the given equation. Alright, so here we go. In this next section, students, we're doing 45 through 48. Now, by the way, just so you know, we did not do 49 through 52 because they're just very repetitive and they're done the same way over and over. Okay, so I'm not going to worry about those right now. But anyways, here we go. Let's look at numbers 45 through 48. The directions say to find all real solutions of the equation. Now, first of all, when you're solving these equations, I'm skipping those, we're not doing those. When we're solving these equations, you always want one side equal to 0. In other words, you want to move all of your terms to one side, okay? So I'm going to bring my 27 over, make it a negative 27. You always want all of your terms on one side. Now that we've done that, yes, you can solve this. It is a quadratic equation. You could definitely solve this equation by using this big old formula like you've learned how to do, and that's fine, okay? But if you can factor, this side over here, factoring is a lot faster, okay? So I'm going to try to factor this left side. Never, students, never factor a polynomial equation unless you have a 0 on one side. It does no good. So always make sure you have a 0 on one side like I do here, like I do right here before you start factoring it. Okay, alright, here we go. Notice I have a trinomial with a lead coefficient of 1. This exponent here should be twice as big as this one, and it is. So here we go. What two numbers when multiplied together give you a negative 27? When added together give you a negative 6. Well, I'm thinking right away of negative 3, negative 9, positive 3. When you multiply those, you get negative 27. When you combine those, you get negative 6. So the factorization would be x negative 9, x positive 3. Now, the next thing you do is take each group and set each group equal to 0, like x minus 9 equals 0. Bring the 9 over and make it positive. But you're big algebra 2 students, I'm not going to work out these parentheses for you. You guys can do that. It's really simple. You can probably do it in your head. So if I take this parentheses here and set it equal to 0, I would get negative 3. So there's my two answers. Positive 9 and negative 3, which is what I have right here. Alright, number 46, same thing. Now, we're going to solve this polynomial function, this quadratic function. First of all, notice I already have one side equal to 0, so that's good. Next, now I want to try to factor. Well, I have a trinomial with a lead coefficient of 1. Those are pretty easy. Make sure your exponent here is twice as big as this one here, and it is. So here we go. What two numbers when multiplied together give you negative 10? But when added together give you a positive 9. Well, that's going to be a positive 10 and a negative 1. If you multiply those, you'll get a negative 10. If you combine those, you'll get a positive 9. So the factorization is x positive 10, x negative 1. There we go. Now take this group, set it equal to 0 and solve, and you'll get this. Take this group, set it equal to 0 and solve, and you'll get this. And there's your two answers. Alright? Okay, let's try 47 and 48. Now, notice I have a quadnomial, okay? Notice I'm solving this equation. It's a third degree equation. I've already moved all my terms to one side, okay? So I'm ready to factor this left side. It's a quadnomial. Always pull out what's common first, but there's nothing common I can pull out. So I'm going to factor a quadnomial. I'm going to pull out what's common in my first two terms, which is x squared, and I'm left with x positive 3. Now there's nothing I can factor out of the last two terms, so I'm going to factor out a 1. But make sure it's a negative 1 because I have a negative sign right here. Because I have x plus 3 here, I'm going to put x plus 3 over here. Let's check it and see if it works. Negative 1 times x, negative 1 times 3, negative 3. So my parentheses do match. So write your matching parentheses once, and then your other parentheses x squared negative 1. Now right away an alarm should go off. Look what you have right here. You have a perfect square and a perfect square, and the first term is positive and the second term is negative, so we can factor that as second parentheses, okay? So I'll put two little parentheses. The square root of x squared is x, so we'll put an x here and an x here. The square root of 1 is 1. We'll put a 1 here and a 1 here. Make one positive, make one negative, and then bring down here that could not be factored again. Now let's solve the equation. Set this group equal to 0 and solve, you'll get this. Set this group equal to 0 and solve, you'll get this. Set this group equal to 0 and solve, and you'll get this. And that's the exact answer we have up here. Alright, number 48. Okay, once again, we're solving a cubic equation, and we want all the terms moved to one side. We've already done that. And we want to pull out what's common over here, but there's nothing common. So we're left over with a quadnomial. How do you factor a quadnomial? Well, you pull out what's common in the first two terms, pull out what's common in the second two terms, and then hope that your parentheses match, okay? So what's common in your first two parentheses? X squared. So you're left over with x negative 4. What's common in these two parentheses, these two terms? A 4. Goes into 4 and 16, make it a negative 4, because there's a negative sign here. And you're left over with x negative 4. Write your matching parentheses once. And you're left over with x squared negative 4. Now, notice your second parentheses can be factored again. Perfect square, first term's positive, second term's negative. So we can take this second parentheses here and factor it into two more parentheses. The square root of x squared is x, put an x here and an x here. The square root of 4 is 2, put a 2 here and a 2 here. Make one positive, make one negative, and then bring down this parentheses here. Alright, and we're good. Take this parentheses, set it equal to 0 and solve, you get 4. Take this parentheses, set it equal to 0 and solve, you get negative 2. Take this parentheses here, set it equal to 0 and solve, and you get 2. Which would be the exact same answers you have up here. Okay? So in this section, what we did is we solved the equation for real solutions, okay? Now we're going to move on to numbers. Let's see here. To numbers 57 and number 62, those two numbers there. Now on number 57, the directions in the book say to divide this by using synthetic division. However, in the directions I gave you, I told you to use long division, so here we go. Make sure that your dividend, or your divisor, excuse me, is written in standard form, and it is. Make sure your dividend is written in standard form, and it is. And here we go. Always divide first term into first term, so x goes into x to the 5th, x to the 4th time, like this. X to the 5th divided by x would give you, cross off an x, cross off an x, you're left with x to the 4th over 1. Okay? After you've divided first term into first term, you take this term here and you multiply it by these two terms here. So x to the 4th times x is x to the 5th. X to the 4th times 3 is 3x to the 4th. Change your signs, negative, negative, and combine and bring down all of your leftover terms. So bring down your negative x squared, bring down your positive 6. Now, make sure this is written in standard form, and it is. Now we're going to divide first term into first term. X goes into negative x squared, negative x times. How do I know that? Because negative x times x is negative x squared. So x goes into negative x squared, negative x times. Take this negative x and multiply it times your binomial. Negative x times x, negative x squared, negative x times 3, negative 3x. Now hold it. I'm not going to put the negative 3x under 6. They're unlike terms, so I'll put it right over here. Alright, let's change signs and combine. Make that positive. Make that positive. These cancel. Bring down your 6. Bring down your 3x. Now, it's not written in standard form, so let's swap these around, okay? The positive 3x should be first. And the 6 should be second. There we go. And now here we go. left with a negative 3, negative 9, positive 6. So you come up here and you take your remainder, negative 3, and you put it over your divisor. And that is your answer. Hopefully it is. I'm going to check the back of the book real quick and make sure we got that correct. And let's see how we did. That is correct. Alright, moving on to number 62. Now, we're going to divide this by using synthetic division. So remember, first of all, run your test on your divisor. First of all, it has to be a binomial, and it is. Second of all, there has to be a power of 1 here, and there is. There has to be a power of 1 here, and there is. So we're good. Remember, you change the sign of this number here. It's a negative 3, so I put a positive 3. And then you're going to write all of your coefficients. But we're missing some that goes 6, then 4, then 3, then 1, then constant term. So let's be careful. I put my negative 2. Then there's no x to the 5th, so I'll put a 0. Then 3 is for my x to the 4th. Negative 1 is for my x to the 3rd. There is no x squared, so put a 0. Then a 1 for my x term. And then negative 2 for my constant. Now remember, you can check this by looking at your degree, which is 6. Adding 1 to it, which is 7. I should have 7 numbers here, and I do. So here we go. Bring down your first number. Multiply 3 times negative 2, negative 6, combine negative 6. 3 times negative 6, negative 18, combine negative 15. 3 times negative 15, negative 45, combine negative 46. 3 times negative 46 is negative 138. Combine, and you will get negative 138. 138 times negative 3 would be negative 24, carry your 2, 1, carry your 1, negative 414. If you combine, you get negative 413. And then if you multiply positive 3 times negative 413, you'll get a negative 1239. I believe I did that in my head, but I believe that's correct. Combine negative 2, negative 1239, you get negative 1241. So here's your answer. This was a 6th degree, so I got 1 less than that, and that would be 5. Okay, so my answer is negative 2x, x to the 5th minus negative 6x to the 4th, negative 15x cubed, negative 46x squared, minus 138x, negative 413. Let's get a little bit of room here, guys. That's your remainder, so plus, and put your remainder over x negative 3. Alright, let me check real quick the answer to make sure we have that correct, and it looks like we do, which is probably a miracle, but we're looking pretty good. Alright, that is the correct answer, so we are good. Moving on. And students, I think we'll stop right there. That's a good stopping place. So that's going to be part 1 of your review sheet for chapter 9. There will be a part 2 later. That's it for this video. If you have any questions, don't hesitate to call or email.